In this video, we're going to look at the average value of a function. And the function here is actually the area of an inscribed rectangle within a semicircle of radius r, with one base on the x-axis. So let's look at a diagram here. We're basically looking for the average value of the area function of a rectangle that's inscribed in this semicircle. So let's think of some of the possible rectangles. Here's one of them. So the distance here, this is the half of the width. This is x. This is y, and so you can see the area is 2x times y. Let's think of another rectangle, like this. So basically, our goal is to find the average value of the average area of an inscribed rectangle within the semicircle of radius r. So we start by looking at the area. The area of the rectangle is going to be 2x times y. And that's because the width is 2x and the height is y. So let's start now by relating x and y. We know that the equation of a circle is x squared plus y squared is equal to r squared. Now, if you want to convince yourself, we can just apply Pythagoras. This is radius r. This is a right triangle, so we get x squared plus y squared equals r squared. That's another way of thinking about that. Let's solve for y. We get y is equal to plus or minus root of r squared minus x squared. So we're looking for the top half of the circle, so we just take y is equal to root of r squared minus x squared. This is the semicircle, the top half of a circle. X is between r and 0. So the area function is going to be 2x times y, and substitute y in, so we get area is equal to 2x times y, which is root of r squared minus x squared. X is between r and 0. And our goal is to find the average value of the area function. So let's do that. So what we have is a average is equal to integral from 0 to r a of x dx divided by r minus 0. This is equal to integral from 0 to r, and the area function, looking at the last page, is this, 2x root of r squared minus x squared. So that's 2x root of r squared minus x squared dx divided by r minus 0, which is just r. So a average is equal to 1 over r integral from 0 to r 2x root of r squared minus x squared. This is a definite integral, and we need to solve this. So what are we going to do? Well, we're going to apply U substitution, because if we let u be the inside function, r squared minus x squared, its derivative will give us a constant multiple of 2x. So let's apply U substitution. U is equal to r squared minus x squared. Differentiate both sides, we get du is equal to derivative of r squared is 0, because r squared is a constant. So that's 0 minus 2x times dx. Now we need to change the limits. We need to change x limits to u limits, because the variable has changed. So x equals 0, plug it into your substitution, u is equal to r squared minus x squared, and we get u is equal to r squared. X equals r, plug it into u is equal to r squared minus x squared, and we get u is equal to 0. So the integral becomes a average is equal to 1 over r. Change the limits, so the lower limit is going to be x equals 0 becomes r squared. The upper limit becomes u equals 0. And what we have is root of u. And 2x dx, this part, we can replace it with minus du. So 2x dx is equal to minus du. So let's put that in, minus du. And if we simplify this, we get negative 1 over r integral from r squared to 0 u to the 1/2 du. All right, let's solve that. So what we have is a average is equal to 1 over r integral from 0 to r 2x root of r squared minus x squared dx. A average, applying U substitution, we obtain negative 1 over r, integral from r squared to 0, u to the 1/2 du. And if we integrate this using reversing the power rule, we get negative 1 over r times u to the 1/2 plus 1 is 3/2. Divide by 3/2, that's the same as multiplying by 2/3. And evaluate this from 0 to r squared. Well, actually, let me fix that. We're evaluating this from r squared to 0. All right, let's simplify this. We get minus 2 over 3 r minus 2 over 3r times u to the 3/2 evaluated from r squared to 0. This gives us minus, so we're applying fundamental theorem of calculus. We're going to put the upper limit in and the lower limit in, minus 2 over 3r times 0 to the 3/2 minus r squared to the power of 3/2. The 2 cancels, and what we get is 2 over 3r, because minus times minus cancels, and it gives us plus 2 over 3r times r cubed. And if we simplify this, we're going to get 2r squared divided by 3. So what we have shown is that the average value of an inscribed rectangle within a semicircle of radius r is a average is equal to 2/3 r squared. It's interesting to compare this to the actual area of the semicircle, which is area is equal to pi r squared divided by 2. So there it is. All right, but of course, this is the area of the semicircle. Let me emphasize this. This is area of semicircle. And this is the average area of the inscribed rectangle within the semicircle. Let's write that neatly, area of semicircle. All right, thank you.